Good evening, Charan.
Good evening, sir.
Right, Charan, Lokesh, right? Let's wait for a minute or two and then we will start. Okay. Mhm. Okay, so work energy power we were discussing, isn't it? And work done by different forces we have discussed, isn't it? With the help of the graph, we have calculated the work done, right? With the help of integration, also we have calculated the work done, isn't it? And if the force is given in I cap J cap formats, right? And both are variable, then we should also keep the displacement in the I cap and J cap format, okay, to get the work done. Okay, right? So let's just start now by calculating the work done by some of forces. Okay, right. Last class, some of the examples also on the work done calculation. Okay, using the graphical method, using the integration method. Okay, now, right? So now let's discuss some of the work done by a common force. Common force means what? The gravitation force and the spring force. Let's try to calculate what is the work done. Okay. So these two forces will come very common to the questions. So what is the work done? Work done is integration of F dot ds, isn't it? Integration of what? F dot ds. If force is constant, right, uniform, then we can directly multiply F dot displacement. Okay. But if the force is variable, then what we should do? We should take help of integration to calculate the work done. Okay. So what will be the work done by gravity? So work done by gravity we are calculating, then gravity is a conservative constant force, isn't it? So any particle is there or any object is there, right? And mass of object is m. So what gravitational force will be acting on that? Mg will be acting, isn't it? And this body is going from this initial point to this another, let's call it what? This is initial point, this is the final point, okay? And it has gone how much displacement? Something h displacement. So if you look at that, see, the gravitational force is acting in downward direction. And if you look at the displacement, that is also in the downward direction, isn't it? So what will be work done by gravity? So work done by gravity will be mg is the constant force, h is the displacement, and as the gravity is acting downward and displacement is also downward, so what will happen? That means the work done by gravity will come what? Positive. Same thing if the particle goes in upward direction, matlab initial to final point, if you see that if the movement happened in upward direction, then what will be the work done by gravity? Then work done by gravity is going to be negative. Understood? So work done by gravity can be positive or it can be negative, both of them, depending on what is the direction of displacement of the particle. Okay, so this is the work done by gravity. What will be work done by spring force? So if you want to calculate the work done by spring force, so how do we calculate the work done by spring force? Now, spring force is not a constant force, it is a variable force. Why it is a variable force? See that. Let's say there is a spring having, this is the natural length of a spring, and a spring has a spring constant something k. Now, you know the spring force is what? If you displace the spring by some x distance, what will happen? The force will start acting on that is going to be kx, and you are going to displace this further by what? Something dx. So here if you see, can you tell me what will be the small amount of work done? The magnitude of force kx, displacement dx, and angle between them now 180 degree, isn't it? Because force is acting towards the natural position and the body is displaced away from natural position, means what? The body spring is being elongated here. So that's why this angle is 180 degree. To get the total work done, what we should do? Let's say initially there is no elongation, that means 0. And finally the elongation is something x. So cos 180, if you write it, minus will come outside, k outside. And if you integrate x and dx, then you are going to get it as the x square by 2. So if you see what is the work done by spring coming to us, the work done by spring is coming minus half k x square. Now work done by spring can be also positive or it can be negative. Okay, so when the work done by spring will be positive and when it will be negative, let's try to understand. Okay, now when the work done by spring is positive and when it is negative. Please keep in mind that whenever spring is being elongated, spring is being what? Elongated, or spring is being what? Compressed. From where? From the natural position. Keep in mind, we are always determining from where? Determining from the natural position. So from the natural length, if the spring is being elongated or compressed, in both cases, what will happen? Work done by spring will be negative. Okay. So work done by spring will be how much it is going to be? Minus half kx square. Okay. Minus half kx square. Where, tell me, what is x is either the elongation or it is the compression. Understood? So here, work done by spring is coming what? It is coming negative, where x is what? Is elongation or compression. It can be anything. Okay. Elongation or compression. And when it will come, x in the formula is always the elongation or compression. But keep in mind, when the work done by spring will be negative, so when spring is being, when spring is being elongated, okay, or compressed. Understood?